Okay, let's conclude our sensitivity kind of excursion here or journey with just a real short summary video. So here's our fundamental insight that we introduced previously. This is our tableau after we've transformed, where the y transpose are the dual variables, which we get from CB transpose B inverse. B inverse is the inverse of the basis matrix made up of the columns of A, as well as maybe some of the identity columns that are underneath the basic variables. And yeah, this is the final tableau, or the tableau after any really transformation for any basis. So here are the different changes. Here are the direct effects, and then the current basis is optimal and feasible if some condition. So really, we made a video or part of a video about each of these possible changes. You can change the right-hand side. It'll have the direct effect of changing the objective value as well as changing the current solution. The basic solution part, the non-basic variables still stay at 0. And then you need to check whether each of those basic solution parts is greater than or equal to 0. If that's violated, then the current basis is no longer feasible, in which case you'd use the dual simplex method to try to work towards a feasible solution. If you add a new variable, then there's no direct effects, that you kind of consider that new variable as being non-basic. And you check check the new dual constraint that you get from that. If that's violated, then that basis is no longer optimal, and so it's no longer dual feasible. And so you can kind of just continue the primal simplex method. If you add a new constraint, there's no direct effects, but you need to check that new constraint. If it's violated, then your basis is no longer feasible. If you make a change to a non-basic variable, NBV, objective coefficient, there's no direct effect because it's not basis, it's not in the basis, it's not really affecting the outcome. But you do need to check the corresponding dual constraint. If violated, then the basis is no longer optimal. Similarly, if you make a change to a non-basic variable column, check the corresponding dual constraint. If violated, the basis is no longer optimal. If you make a change to a basic variable objective coefficient, then CB changes, your dual variables change, and your objective value changes. You're going to need to check the dual constraints for all non-basic variables. So you're going to need to check that the dual variables are non-negative and the dual constraints are satisfied. Okay. But you only need to do that checking for the variables that are non-basic in the primal problem. Finally, if you make a change to a basic variable column, everything changes, and the effects of changing are non-linear and harder to kind of quantify or deal with directly. I once tried to show an example of what changes here. You get a lot of like rational functions, or kind of, yeah, not at all simple or easy to deal with. Might as well think about a specific change that you might make to this, and then make that change and see what the effect is. Okay. Follow up. If the current basis is no longer optimal, continue with the primal simplex method. Keep moving towards optimality. If the current basis is no longer feasible, use the dual simplex method to move. So then you're going to be starting off dual feasible, but you're going to move towards dual optimality, which will bring you to primal feasibility. So there's a lot of kind of interplay between what we covered previously in duality and these videos in sensitivity. And so knowing one helps a lot with the other. But yeah, this was a short summary of sort of the fundamental insight, and then what happens with each of the possible changes that you could make to the parameters of the problem, their direct effects, as well as when you would then need to sort of continue in your optimization, either with the primal simplex method or the dual simplex method. That's it for this video.